Last class we discussed about the short transmission lines, and apart from that we also discussed about the ABCD parameters of end condenser method. Today we are here to discuss about the important phenomenon called as resonance. So resonance is an electrical phenomenon that occurs in the field of telecommunications. So resonance, if you are trying to look after the applications of resonance, when one wants to identify a particular radio station from available different radio stations, the principle that is applied is resonance. And apart from that, when a particular consumer wants to utilize only a particular TV channel out of different TV channels, we need to take the assistance of resonance. The resonance is a very important electrical phenomena that happens everywhere as far as the electrical phenomenon is concerned. So we'll try to explain what exactly is we have explained about what exactly is resonance, and trying to speak with respect to the resonance, we had here with different modes of operation that is supposed to speak for resonance. So when you are trying to speak for resonance, it operates either at a lagging power factor case, or a leading power factor case, or a unity power factor case. So I'm supposed to speak about the resonance. And this is the waveform diagram that defines the resonance. So this is my resistance R, L, C, and it is connected to a voltage source. It is an AC voltage source with voltage V is equal to Vm sin omega t. V is equal to Vm sin omega t. And see here, so as far as the electrical resonance is concerned, we are here to vary the important parameter called as the frequency. Okay, once the frequency is varied, obviously resonance can also be established in an electrical circuit. So assume that frequency is varied, and I am supposed to speak that voltage is held constant. Voltage profile is held constant, and the frequency is only the term that can be varied. Okay, and see here, so as far as the resonance is concerned, we need to speak that either it can operate in lagging power factor, or leading power factor, or unity power factor. The ability to identify a particular radio station among the different radio stations, we call it as the help of your resonance. So when resonance occurs, XL is equal to XC. XL is called as inductive reactance, and XC is called as by capacitive reactance. So XL is equal to 2 pi FRL is equal to 1 by 2 pi FRC. So in other words, I can say that FR square is equal to 1 by 4 pi square LC. FR is equal to 1 by 2 pi root LC. So when I want to establish the resonance, I need to vary the frequency so that the resonance can be varied, or else the other way to obtain the resonance is either by varying the value of L, or either by varying the value of C. Resonance can also be obtained. So one has to identify such that the product of LC, if it remains constant even after the variation of L and C, the resonant frequency cannot be varied. So the fact is that if LC product is held constant, resonant frequency cannot be varied. And if I want to vary the resonant frequency, either I need to vary the value of L, or else I need to vary the value of C, such that the resonant frequency can be varied. And when you are supposed to vary the value of resistance, it has no effect on the resonant frequency, because FR is equal to 1 by 2 pi root LC. So in this particular equation, in this particular equation we have not mentioned in terms of resistance. So even if I vary the value of resistance, the sharpness varies. Okay, the sharpness only will be varied and rest everything will remain constant. So quality factor is equal to, we had an equation, quality factor is equal to FR by bandwidth. And see here, bandwidth is the difference of two frequencies. One is called as F1 and second one is called as F2. As I said earlier, the first thing is that either the circuit operates either at lagging power factor, or the circuit operates at leading power factor, or a circuit operates at unity power factor. That depends upon the value of my value of the frequency. So F1 is the frequency at which the voltage across the capacitance is maximum, and F2 is the frequency at which the voltage across the inductance is maximum. Okay, and next thing is that, okay, we need to identify the so this is my resonant frequency FR. So it has to be varied from 0, and this is my frequency, and it is given, y-axis is given for two different parameters called as Z and I. So initially the Z is maintained with maximum value, as I said earlier. Okay, as I said earlier, if the frequency, if it is varied from 0 value, obviously the voltage that will appear across the inductance will be short circuited, and the total voltage, that is V is equal to Vm sin omega t, will be applied across the capacitance at initial stages. Okay, at initial stages when you are trying to vary the frequency, if frequency f is equal to 0, when f is equal to 0, okay, so xc is equal to, we had an equation that is 1 by 2 pi fc. Since frequency is maintaining with a 0 value, xc will be infinite. Okay, it goes up to infinite value. So once if frequency is made a 0 value, xc is made to infinite, obviously, okay, so the inductive reactance across the capacitance will be equal to infinity, and total voltage will be applied across the inductance and this across the capacitance, and this inductance will become 0. The inductance will be short circuited. And if, as I said earlier, if frequency is varied in such a way that if the frequency is varied, the value of xc starts reducing and the value of xl starts increasing. Once the value of xc starts reducing, obviously we had an equation z is equal to r plus j into xl minus xc. So prior to my resonant frequency, okay, the impedance is purely related to the capacitive nature. Okay, prior to my resonant frequency, impedance is purely capacitive nature. Impedance is purely capacitive nature. Similarly, when frequency is increased in such a way that when XL value, if it is identically equal to XC value, okay, and 1 by 2 pi FR L is equal to 1 by 2 pi FRC. So FR square is equal to 1 by 4 pi square LC. FR is equal to 1 by 2 pi root LC. So in such cases, at this location, okay, the current value will be maximum and the voltage across the current value will be maximum and the impedance value will be minimum. At this location, the impedance value will be minimum. After my FR value, after crossing the FR value of frequency, obviously the impedance value starts increasing because Z is equal to R plus J into XL minus XC. So already we discussed that XC is reducing, and when XL is equal to XC, the two values, they are equal in magnitude but exactly placed by 180 degrees apart, so they cancel each other. So at F is equal to FR, the voltage that is available to the combination of RLC is provided only across the resistance, and these two, the voltage across the inductance as well as the voltage across the capacitance will be equal in magnitude but exactly placed 180 degrees apart, so they cancel their effects, and the total voltage that is available across the RLC combination will be given only across the value of R. And if frequency is beyond my resonant frequency, okay, so inductive reactance value starts increasing, and at the same time the capacitive inductance, the capacitive reactance value starts reducing. So the impedance value starts increasing, okay. And when frequency FR is equal to infinity, okay, when frequency value frequency F is equal to infinity, in such cases Z is equal to R plus J into that is Z is equal to R plus J into XL minus XC value will become 0, because XC is equal to 1 by 2 pi FC. When frequency value is identically equal to infinity, 1 by infinity will be 0, obviously XC value will be equal to 0 and XL value reaches to infinity. So thereby the total applied voltage will be applied across the inductance. Initially the applied voltage will be applied across the capacitance, and later on it has been transformed to the applied voltage will be applied across the resistance, and finally the applied voltage will be applied across the inductance, making the making the capacitance to get short circuited. Because the fact is that when XC value, when XC is equal to 1 by 2 pi FC, when F is reaches to infinity, XC value will become 0. XC value becomes 0 in the sense, that is, I need to say that the capacitance will become short circuited, okay. So capacitive reactance will become 0, okay, thereby, okay, this capacitance will be short circuited and the total voltage will be applied across the inductance. Next, again see here. So as far as the resonance is concerned, so we had an equation related to the value of pi. Pi is equal to tan inverse of XL minus XC by R. We had an equation related to pi angle. So pi is equal to, this is otherwise called as pi, and it is represented with 0 degrees. So pi is equal to tan inverse of XL minus XC, and I was explaining here regarding the concepts of resonance. When resonance occurs, okay, the value of XL is equal to XC. So XL minus XC will become 0. So 0. So we need to speak for the angle for tan. Okay. So for tan it will be quite equal to 0 degrees. Okay, because tan 0 is 0. Okay, it starts from 0 degrees. So the value of FR, the value of angle at FR frequency will be given with 0 degrees. So at the same time, if you are maintaining a huge capacitive reactance in the network, okay, where it is quite equal to the capacitive reactance, if it is equal to infinity, okay. So when XC value is quite equal to infinity, XC value if it is quite equal to infinity, so thereby you can obtain the angle to be as 90 degrees with minus 90, okay. So its journey starts from here, okay. So as far as the frequency is increased in such a way that, okay, the inductive reactance starts increasing, okay, and the capacitive reactance value starts decreasing. So in such cases, at a particular frequency, the two are equal in magnitude but exactly placed 180 degrees apart from each other. The two values are equal in magnitude but exactly placed 180 degrees from each other. So thereby, okay, so at FR value, okay, the two values are equal. I have shown here. So this is my Vs and it is shown here, and this is my VC, okay, and this is my VL. So maximum voltage at which the VC, the maximum voltage at which the VC, for which VC occurs is F1, and similarly the maximum voltage across inductance where we can obtain a frequency that we actually called as F2. So we had here with two frequencies, one is F1 and second one is my F2. F2 minus F1 will be my bandwidth, and F4 divided by bandwidth will be my quality factor. Okay. So as I was explaining here regarding the concepts of resonance, once the resonance occurs, okay, the two values, they are equal in magnitude but exactly placed 180 degrees apart from each other, so thereby they cancel each other. That is shown here. Okay, so this value and this value both are equal at this particular frequency FR value. Okay, these two values are exactly 180 degrees apart from each other, so thereby at this value they cancel each other, they cancel their effects each other, and okay, and at this location you can find the FR value, and at FR value, okay, the current will become maximum and impedance will become minimum. Okay, so beyond my FR value, okay, beyond the FR value, so see here, beyond my FR value, obviously, okay, this will be the voltage across the capacitance will be reduced. Okay, and at the same time when frequency is increased, when frequency is increased beyond my F2 value, okay, obviously again the voltage across the inductance is also reduced. Okay, and apart from that the voltage across the resistance will also become zero. Okay, so thereby will also become reduced. Okay, and finally the fact is that, okay, the IR drop, okay, IR drop across the resistance will be reduced. Okay, similarly the voltage drop across the inductance will also be reduced, and the voltage drop across the capacitance also reduces. Okay, but the fact is that the voltage will remain, the voltage that the sending in the applied voltage will be applied completely across the inductance, because we can ensure that a open circuit will be applied across the, we can ensure open circuit will be applied across the inductance, making the capacitance to get short circuited. Okay, and that is shown here. Okay, and XL is shown in upward direction, whereas XC is shown in downward direction, and this is my FR. Okay, at this location the inductance value, okay, the impedance value reduces. Okay, and after this the impedance value starts increasing. At the same time, this is what we have shown for the capacitive reactance. Okay, it starts from infinity value. Okay, once the frequency value is increased, okay, so this becomes zero then. Okay, and see here the voltage, we don't have any effect on the resistance, as I said earlier, because we can find, okay, we can find the only that is the selectivity. Okay, selectivity plays a vital role in resonance. Okay, so sharpness, okay, this is otherwise called as sharpness. Okay, so this is my sharp frequency where the, okay, resonant frequency can be obtained. Okay, so sharpness will be varied when you vary the value of the resistance. Okay, we don't have any significant value in varying the resistance, because only the fact is that, okay, let us assume that if you are supposed to keep with one more value of resistance, okay, the current value will be increased but the resonant frequency cannot be increased. Okay, so thereby, okay, we are unable to identify where exactly is the resonance occurs. Okay, so in order to identify, or in order to select that particular resonant frequency of R, okay, the only way to identify the resonant frequency is by varying the value of the resistance. So if resistance value is increased, obviously the sharpness value increases. Okay, so thereby it is easy for us to identify the value for the resonance frequency. Okay, so and here what I would like to mention here is that, okay, once the bandwidth is reduced, okay, as I said earlier, so quality factor is defined as the ratio of resonant frequency to the bandwidth. Okay, once the bandwidth value reduces, the quality factor value increases. Okay, and see, okay, that means once the bandwidth or the difference of the two frequencies is reduced, okay, so it is operating in such a way that it operates like band pass filter. Okay, the resonance circuit operates like a band pass filter where, okay, it passes certain amount of frequencies available between f1 and f2 and it all rejects the other frequencies. Okay, once if we keep the bandwidth value as minimum as possible, the quality factor is increased. Okay, in other words I can say that if you are maintaining very low amount of the frequency that is available between f1 and f2, okay, so quality factor will be increased. Okay, and it is easy for us to identify the fr value. Okay, so for some TV channels or for radio stations, okay, it is easy for us to identify the set of frequencies where the required station can be established. Okay, so we need to vary our frequencies from 1 megahertz to another megahertz. Okay, that might be given a fraction value. Okay, it cannot be a major value, but the fact is that the unknown station can be obtained easily by varying the potentiometer of the radio station, such that the unknown station can be obtained very easily. This is all about the resonance, and if you had any doubts related to the resonance, okay, chat with me in the chat box, and rest of the things we'll see it by next class. Thank you.